Yeah, okay, fine. Now we will move on to the session 3. We have learned about your BJT and FET. Now we will see what is the difference between the normal BJT and your amplifier. Okay, from the name itself it is evident that it is going to amplify your input or any weak signals. Okay, now when I say it as an amplifier, it just raises the strength of the weak signal and thus it acts as an amplifier. Okay, suppose whenever I am going to use the microphone, I have to use the amplifier. Okay, and then it is going to given out through the loudspeaker. So this amplifier setup, it can be any one of the thing, either a CE amplifier, CB or a CC amplifier. Now, if you could see the transistor amplifier, okay, the CE amplifier, what you have done first to draw the common emitter configuration. Of course, you have to give your input biasing and the output biasing. So, what is the need for biasing? Whenever only if you give the biasing, the system will work properly at its Q point or quiescent point or your operating point. Now, here I am going to apply my signal. So whenever I am going to apply my signal, what happens? This DPP is going to provide a forward bias. As a result of this, my output waveform, input I am going to give like this, output I am going to get like this. What does it enforce? It enforces whenever I am going to give the waveform, at the output, the waveform is getting magnified. When it is getting magnified, as well as here, if you could see, you see a phase reversal in it. Okay, so that is the characteristics of your CE amplifier, whereas other two amplifiers do not have this characteristics. So we will see why this occurs. Okay, now we'll just see the KVL equations. Whenever I want to write my input voltages, it is going to be nothing but the whatever is this IBRB drop plus your VBE. Okay, and similarly at the output side, if I want to see, so what is your VCE? So this VCE is nothing but whatever the voltage VCC minus this drop will give you your VCE. Or in other words, this VCE plus ICRC drop will give you my VCC. Anyway, you can write it. Now we will move on to the thing how the waveform is getting. That is why the phase reversal is occurring. You know the general output characteristics of your CE configuration, where you are going to plot the output current IC versus your output voltage VCE at constant input current. So this one you know, and this general equation we have written from the previous slide. Okay, in this slide just add two capacitors C1 and C2. So this is going to provide the isolation between your input and output components. Now what you are going to do? So whenever you are going to apply the input signal, as a result IB is going to increase. You know what is the gain formula? Beta is IC by IB, or else in other words, when the input current increases, output current is going to increase, and vice versa. For suppose if I am going to decrease my input current, then my output current also will decrease. Okay, so now 1 minute. Okay, so now this variation of current. Okay, so this what is the understanding from this? So whatever is going to be my variation here, accordingly I am getting a variation in the output. Okay, if ever I am going to get my IC as increasing. When I am getting the pen, okay. When my IC is increasing, in that case my VCE will decrease. That is the concept. So only I am getting whether when this is increasing and this value is decreasing, and I am getting a phase reversal, because whenever the starting, whenever my IB is going to increase, correspondingly my IC also will increase. When IC increases, so this VCE is decreasing. Okay, or in other words, when IC is increasing, this VCC output voltage is decreasing on that one.